So this is the first video for Breakout. If you'd like to go ahead and download the source material, which is across on that side, just click on the link there. The link is also just below us as well. Download the zip file. If you extract that zip file, inside there you'll find a folder called Breakout Start. Inside there there's one called Assets. Inside there's one called Scenes. Inside Scenes there is a scene called Game. And if you double click that file, then it will open up Unity and we will get started. To make things a little bit easier for this, I made the game so that it fits on a 16 by 9 screen perfectly. And the way I did that is I have 16 units across. So this is Unity units. So I've got 16 units across by 9 units down. And I changed the main camera so that it is orthographic because it's just a 2D game that we're doing just now, and I changed the size so it's 4.5. so that means that, and you can see here from the camera preview, everything fits inside this square, this rectangle here. So if I go to the game, no matter where I rescale it to, everything stays the same place. So I have 16 units along here and I have 9 units down here, which makes 16 by 9, which is what I have up here. So to fit the graphics in, all the graphics, so if I go to the brick, for example, everything is set to 16 pixels per unit, which means that for every 16 pixels you go along, you go 1 unit in Unity. So 1 Unity unit, for lack of a better word, is worth 16 pixels. So that was the general idea anyway. So I wanted to keep this game as simple as possible, and so that's why. So the bounding box for this, right bang slap in the center here, is the origin, and so the extremes here are 8 along here, -8 on this side, and then at the top here is 4, and then we have -4 at the bottom, because y goes positive along to the top of the screen and negative towards the bottom of the screen. So that was the sort of idea behind it anyway. Okay, so let's get rid of the test card just now. We don't actually need it. Alright, so our two main characters, if you like, in this game are the is the paddle and the ball. So we are going to drag those out into the screen hierarchy. So we have our ball and we have our paddle. Now you can call these anything you want. I'm just going to call them ball and paddle because that's what they are. And for the paddle, I'm going to specify -4. So I'm going to send the paddle right down to the bottom. And for the ball, I am going to send its position to -7.75, which puts it right on the edge of the screen. So the ball is over here and the paddle's over here. And I'm going to save the scene just now. So that's everything set up. So now we're going to have to add some other components to our objects here. In fact, let's just get rid of the test card altogether. So the ball, we're going to add colliders to both of these objects because we want to be able to determine when one object hits another object. So when the ball hits the paddle, it's going to reflect off the paddle and move in another direction. So in order to do that, we have to add things called colliders to it. Now because we're using two-dimensional objects, we're going to use two-dimensional colliders. So if I go to my add component and I type in collider, I see that I've got a box collider 2D, so I add that one, and I do the same thing for my paddle. Now colliders only work in Unity if one of you is a rigid body, so we need to add a rigid body to one of them, and the most obvious contender for this is the ball because it's really the only one that's dynamic. It's the one that's moving around the playing field, so it's going to crash into walls, it's going to crash into bricks, it's going to crash into the paddle. So it makes sense to put the rigid body here. Now make sure when you do add the rigid body that you add a two-dimensional rigid body. And the most important thing here is when you do add the two-dimensional rigid body, make sure the gravity scale is 0. we don't want to be affected by gravity. We are actually going to manipulate the speed of the ball itself in code. So yeah, so just make sure that that's set to 0 there. Okay. And that's it. I mean, if we run the scene just now, nothing's going to happen. It's just gonna, you're just going to get a paddle there, and you're going to get a ball there. So we haven't actually written any code yet. So we're going to change that just now. We're going to add code to move the ball around the screen. So if we go to our scripts folder here, and then create C# script, and we're going to call this one move ball. And it's a very simple script. We're going to start building on it, obviously, but at the very start it's a very, very simple script. So we're going to drag that over to and onto our ball object here in the hierarchy. So now ball has a move ball script. Okay, so to open this script inside Visual Studio or inside MonoDevelop, whichever one you've got, you double click the script. Okay. Okay, so the first things we're going to do is we're going to add some constants to our script so that we don't have any magic numbers in there. The thing we're going to add is we're going to add the two fields we're going to add are the left and right edges of the screen with respect to the ball. Now the ball itself, if I go quickly back to the ball here, the ball itself is 16 pixels, but it's actually only 8 by 8 pixels. So I did some calculations offline. So the left and the right hand sides of the screens are actually 7.75 units based on our 16 pixels per unit. And the top and bottom is 4.25 as well. I've got a couple of notes over on the other monitor, that's why I'm looking over here. So I'm going to have our read-only float values of left, right, equals 7.75, float, read-only float, and top, bottom. So these are our extremes. We're also going to have a private variable for our speed. Now our speed is in two axes. We actually have an X direction and we also have a Y direction, so that's going to vary across there. So to start off with, our speed is going to be 4 minus 4. So this is 4 units per second. Now everything is done timed per second. So this is 4 units per second. So that's 4 units per second along on the X-axis and minus 4 units per second on the Y-axis. Remember, the Y-axis goes down the screen. Sorry, the negative Y goes down the screen, I should say. And we have a variable here called ball served, and this is currently set to false because we don't actually want to move the ball unless the player has hit the fire button. Now by default the first fire button is the left control key, or it is the left mouse button on the mouse. So we're going to use coroutines to move everything around, but to start the ball rolling, we are going to check to see if the fire button has been pressed. So we are only going to serve the ball if the fire button's been pressed and the ball hasn't been served yet. So usually when you have a toggle like this, you immediately want to turn that toggle off. So we have our Boolean value here for ball served, so we want to set that to be true. So we're going to start serving the ball. And we're going to create a coroutine called run. So the run coroutine is the one that's going to bounce the ball around the screen. So the first thing we need to do is we need to determine how fast the ball is going between this frame and the last frame. And this is done using a delta time calculation. So this is the delta time is the time between this frame and the previous frame. And that's the calculation there. So we want to find out the delta, the distance, which is just a very, very simple physics calculation here. So we take the speed and we multiply that by the time, and then that gives us our distance that we've travelled in that time. So our new position is our current position, plus our new offset. So now what we need to do is we need to test to see if we've hit any boundaries, and if we have hit any boundaries, we want to reverse on that direction. So if we've hit something on the left hand side, so the right hand side, we want to bounce back on that side, and similarly if we have hit top and bottom, we want to bounce back on those sides as well. So we're going to do if new position is less than, so remember everything starts in the center of the screen, so our left hand side of the screen is going to be our negative value here. So let's take this, these are very similar to each other. I'm only going to talk you through this one. Hopefully you'll get that, and then the other ones will sort of follow. So we're going to check to see if the x value is less than the left hand side of the screen, and if it is, we are going to reset the position to the extreme left hand edge of the screen, and then we are going to invert the x speed. So if it's doing +4, it's going to be doing -4. So the next time when we come back in here, it will be in the opposite direction. So we'll be adding a negative number if it was positive before, and we'll be adding a positive number if it was negative before. And then we do the same thing for the rest of these. So if new position.x is greater than left right, so in this case we're dealing with the top part, so we're going to negate on the y, and we're going to set it to be the topmost unit. So this is only going to run once though, so we need to keep it running for the entire game, or at least until something happens. So we're going to do this while ball served, and then wrap all of that inside a while loop. So while the ball is served, we're going to move the ball around the screen. So while the ball keeps on getting moved, you want to update the screen. But inside here, inside the while loop, we really need to tell Unity to go about and do other things. So in order to do that, we actually use this statement here called yield return, and then we're going to specify a new time, so that in this case we're just going to wait for the end of frame. And then at the end of the frame, we're going to then recalculate all of this. So this is going to keep on coming back in at the end of the frame, and then we're going to update the ball position here. Just before our yield, we are going to have to, so we've calculated our new position here. We actually want to set our new position so that we move the ball. So now our ball moves. Now you notice that something strange happens when the ball moves. Actually, when it collides with the paddle, it rotates a little bit. Now we can fix that. If we have our ball selected, just go over to our rigid body 2D and then click on freeze rotation on the Z-axis. Now the Z-axis is actually pointing that way, so the Z-axis is pointing towards the screen, so any rotation happens along the 2D plane of the X and Y. So now that will prevent our rotation. Now that we have our ball moving, we can get our paddle moving as well. We're going to use the keyboard for this, just the left and right arrow keys to move, and like I said, the left control to serve the ball. So yeah, let's go ahead and go down to scripts, and we're going to create a new one, and we're going to call this one move paddle. And move paddle is going to be added to our paddle object. And if we double click that, we'll reload this. Oh, this is the worst thing. This is the worst. Forget about getting stung by jellyfish. This is the worst. Okay, so we have our move paddle. It is a mono behavior. For those of you who are coming to these videos fresh, you haven't seen this before. I can't remember if I've explained these kind of sort of little idiosyncrasies. But over here in the hierarchy, we have our game objects. Now, game objects are just points in space. That's all they are. They're just literally just points in space, and they have a few methods attached to them, but effectively they're just a point in space. And what you do is you add components to them. Now, there are some components that are built into the system, like Sprite Renderer, Box Collider 2D, Transform. Well, Transform is actually part of the game object itself. But you can create your own components, and that's what we're doing here. When we create a script, we create a component. Now, when you create a component like this, you have access to everything that the game object has got access to, including the position of the object, which is accessed through the transform property. So that's what we did with our move ball, and that's what we're going to do again with our move paddle. Okay, so we're going to create, if I can type. So the edge of the screens, according to the bat, which is 4 times wider than the ball, it's 48 pixels wide, which is 3 units, because 48 divided by 16, remember we've got 16 pixels per unit, so that gives us 3 units. So it's 3 units wide, which means that from the center of the paddle to the outside edge of the screen is 6.5 units. So that's negative 6.5 units that way, and positive 6.5 units along to the right. And the speed of the ball is 6. Now we don't have any update methods. We don't have any start method. We don't need that. The only thing we need is the update method. And again, we're going to use delta time when it comes to calculating the position of the paddle based upon the user input and how fast we want it to move. So it's 6 units per second. So first things first, we want to grab a copy of the current position of the object. So that's it. That's how easy it is. We grab the current position of the object, which is through the transform, which contains a whole host of other things that we're not going to go into right now. But then the thing that we are interested in is the position, so we want to make a copy of that. So that's what we're doing here. So now we want to find out how much distance we've traveled in that time. So we're going to capture the horizontal axis, which is our left and right arrow keys. That's the default set up by Unity. Multiplied that by the delta time, multiplied by the speed. So get axis horizontal times time dot delta time times speed. I should also point out here that capitalization is king when it comes to C#. Make sure that your vector 3 is capital V, your update is capital U, and your horizontal is capital H, amongst other things. Make sure you get your capitalization correct. And then that's all we're going to do. We're going to add the delta to the current X position. And then we're going to check the edges and make sure that the paddle hasn't gone off the edges. So if pos.x is less than minus edge, else if pos.x is greater than edge, and then the last one of this is transform.position equals pos. And that's it. So we get a copy of our transform position. We calculate the delta difference. So if the user hasn't typed in anything, if it hasn't pressed any keys, the player hasn't pressed any keys, that's going to be 0. So anything multiplied by 0 is... we then add that delta to the position, the current position. Remember, this is our copy of the current position. And then we do a couple of checks to make sure that we're in bounds inside the screen, because we don't want to go outside the screen. And then eventually we set the position back to our newly calculated position here. So when we play the game, and I use my left and right arrow keys, my paddle is now moving on the screen. So when I serve the ball, oh dear. Well, that's not quite right, is it? So we are going to fix that in our next video, but for now we have the basics of our bat and ball moving. Okay, I can't leave it at that. We need to fix that collision. That's just not good enough. Let's go ahead and do that. So in our paddle, we are going to change that to player, because we want to check to make sure that our ball has hit the player, and the paddle is the player is the paddle, so we're going to put it as a tag. We don't need to do anything special. These are actually put in here by Unity itself, so we are good to go for that one. Alright, so in our move ball script, we're going to add a new method called this is very important that you get the spelling and capitalization right on this one. So this is on collision enter 2D, and we want to check the game objects tag of the thing we just collided against. So if I do C game object dot tag equals player, I am going to bounce it back on the y-axis. So it's as if it hit the bottom of the ground. I want to bounce it back up again but only if I hit the player. If I hit anything else, I don't really care. So now, when I play this, boom, I now have my ball moving perfectly. If you liked the video, then thumbs up. If you didn't like the video, then feel free to put thumbs down, but please leave a comment below. I like feedback. Who doesn't? And yeah, I'll see you next time, where we will be adding a brick wall. So some things that we can destroy in the game. So yeah, until next time, thanks very much for watching.